Hi, welcome everybody to the first solutions track. I'm here today to talk about the 3 common pitfalls in microservice or orchestrate integration. Before I get started, I want to give credit to Bernd Rucker. He's our co-founder of the company that I work with. He's a developer advocate, and we wouldn't be here if it wasn't for him. So I just want to say thank you to him. I am Patricio Zambrano, technical consultant with Camunda, Inc. This is our agenda for today. It's a bit lengthy, and so to that extent, I would like to leave the questions that you might have until the end, if possible. But if you really, really have a question, please let me know. All right, so the first thing that I want to get started with is, I want to do this a little bit more interactive. So I want to ask of you, and I will ask of you to raise your hand if you are familiar with REST. Yes. Good, good. Second one, are you familiar with microservices? Good, good. Thank you very much, Andreas. And the third one, are you familiar with Java? Who in here is a Java shop? Who uses Java in their organization? Okay. That means this presentation is going to be interesting for you. All right, so let's get started. Distributed systems. I'd like to show you what distributed systems is through this image, okay? Imagine, and of course some of you are developers, right? You're living in this little red house that you see, and it's getting smashed by waves and by thunderstorms and by wind. This is the feeling when you start working with distributed systems. Why? Because there's a lot of challenges. Number one is the communication between the microservices. There are some challenges there. Number two is whether or not you want to communicate between your microservices asynchronously or synchronously. And the last one is distributed transactions. How to maintain consistency between your microservices. Right? But what better way to get started with an example? Before I jump into the first demo, I'd like to show you this. Okay? Let's imagine you have all of these applications, all right? All of these microservices, you're running them. All of a sudden, one of them fails, right? The important thing to consider here is that failure will happen, okay? Unless Superman or Wonder Woman coded this for you, but I don't think so. The important thing is to keep it local, to keep it resilient. Don't let the fire spread to the other services. Don't let one failure affect the other services. So, to better demonstrate, let's do a demo, okay? In this demo, what I will show you is 2 microservices. Okay, the payment application and the credit card application, okay? We're also going to use Postman, right? Postman is the payment requester application. Imagine this as an external system that is requesting a payment, and then the payment service through the REST API is requesting a credit card charge. Very simple. So the first scenario is, what happens if the credit card service is super slow? Do you guys know maybe what will happen? Maybe raise of hand. Okay. There you go. Yeah, of course. Payment service is going to be very slow. Now, who is familiar with a circuit breaker? All right. So a circuit breaker in a house, if there's low electricity, what the circuit breaker does, it cuts out electricity of your house. Now, in the programming world, right, there's also a circuit breaker. One of them is produced by Netflix called Hystrix. Okay? The circuit breaker, what it does is when a service is slow, it will cut the power, basically. It will say, hey, it's very slow, it's not working. So how does this work? And this is very useful because it prevents things from spreading, right? The failure from spreading in your applications. So what I'm going to show you now is how does this circuit breaker work? Okay, Here we go, 1, 2, 3. Again, the credit card service is slow, but this time, because it's so slow, we get an immediate error. All right? The circuit breaker stops that and says, hey, I'm sorry, this is not going to work. A little bit better than just loading and loading and making other things fail. Okay? So failing fast, as you can see, is very important. But the reality is that it is not enough. All right? And the best way to illustrate this is by another example. Who in here has ever flown on an airplane and checked into the airline, right, to get their ticket? Good? All right. So personally, I've had to travel all over the world to make presentations, right? And when you're trying to check into your application, to your airline, to your flight, well, you go to the user interface, right? You check in, and then you expect a ticket. Sometimes this doesn't work, right? It's just things happen. Failure will happen, right? So you can get an error like this. Hey, sorry, we cannot give you your ticket, so please come back later. Not a very good thing, right? You can't fly back, basically. So what I imagine that is happening in the backend is something like this, right? You have the web user interface, right, where you're using it to check in. Later on, the check-in application, right, calls a barcode generator, right? This barcode generator is the one that has the ticket, the airplane ticket. But for some reason, it fails, because failure will happen. Now, this is not very good, right? But you know, hopefully at least they have a circuit breaker that they're using to throw out an error and stop things from spreading. So that's kind of okay. Right? And this is just another screenshot from another one of my not-so-favorite airlines that I sometimes use. Right. So what's happening here? All right? So you have all these microservices, right? And right in between the check-in application and the barcode generator application, something goes wrong. And because something goes wrong, me, the user, or whoever's trying to get their airplane ticket gets an error. And it fails. So in my situation, if I cannot check in successfully, I will try again 10 times, 20 times until the code confesses to me. Tell me what's wrong. Or at least you will maybe call the airline and be, hey, where's my ticket? Right? Depending on how you want to go about things. Not very good. Here's another example, another airline. Hey, we're sorry, we cannot give you your ticket. Come back later. What? That's not very good. This would probably be a little bit better. Hey, we're sorry, we cannot give you your ticket right now, but we will send you the ticket in the next day, 10 minutes, next 10 minutes, 20 minutes, so don't worry, you will receive your ticket soon. This will probably be better. How can we do this? So what you want to do is you want to contain the error between microservices, between the check-in and the barcode service here. That's what you want to try and do. Right? You don't want the failure to leave the scope and affect the user. So how do we do this? Right? Well, we can do this by handling state. Right? In the classic way, in the normal way, well, you can just do a persistent thing, such as using an actor, a document, or an entity, right? The simple way. This, of course, can bring a little bit of complexity to things because, well, it requires a lot of effort, a lot of resources, but, well, it's do-it-yourself type of approach, and that's okay. Because the reality is that you still need scheduling, you still need versioning, you still need operation, and you need to be able to know what's going on in your microservices, and that's just the reality. So this is where the fun part begins, right? Well, why not use a state machine or a workflow engine? Now, most of you might be thinking, oh, the workflow engine is something very centralized. It's old school, right? But it's really not. right? Today, there's so many solutions that can allow you to handle state and solve these type of problems, okay? These are the problems that we just went through, right? So work engines can be slow, they're very heavyweight, they're not open source, right? But that's not really true, okay? And today, we're gonna dive into workflow engines. Okay, so let's talk a little bit about the workflow engines or state machine market. Okay, today, there are serverless options, such as AWS step functions. Really good. It can be used to orchestrate your tasks. There's also some open source options, Uber Cadence, Netflix Connector. Now, these options are a little bit company-centric, meaning that they have developed these solutions very focused on their own organization. They're still open source, but not very friendly because of that. Then we have, of course, open source options, such as Camunda, CB, JVPM, and Activity, right? CB, for example, can scale in terms of performance, right, at the same speed as Apache Kafka, all right? This is a personal test on a local computer on how many events can we process when compared CB versus Apache Kafka. We're not going to talk about that today, right? CB can also help you orchestrate your business processes. But for today, we're going to talk about Camunda, right? Camunda BPM. All right, so let's do another demo. First, let's kind of do a quick recap. In the previous demo, all right, we saw what happened when the credit card service was too slow. The payment service just failed, right? That was the demo, right? But what you really want to do is you want to make your payment service asynchronous, meaning that even if the credit card service is slow, and which would make the payment service fail, you can make it asynchronous, meaning that if the payment service fails, it will try again later. Okay? Imagine that you can do this with a workflow engine, right? You can set job retries. You can say, payment service, if the credit card service is slow and you fail, I want you to try 5 more times, right? So how can you do this? Let's jump into the demo. Okay. All right. With the Camunda workflow engine, right, you have different ways that you can go about this. One is you can use Java, and you can construct or make a process from Java code. You can also use a user interface, right, and deploy a process model onto the engine if you want to. In this case, we're using Java because I think you guys would like it more. So what I'm going to show you here, what we have here, we want to focus here on this part over here. What we're going to be doing now is the payment service is, we're going to create a process. Okay, as you can see, first we add a start event. All right, so our process has a start event. Later on, we create a service task with the name Stripe. Actually, with the ID Stripe and the name async task. This task has a delegate expression, meaning that you can implement code with this task. You can call Java code, or if you want a script, anything like that, with this task. Later on, what we're doing over here is we're making this task asynchronous. Okay, meaning that when the requester makes the request, it will tell the requester, hey, yes, I received your request, everything's okay, but maybe not accepted. Even if it fails, it is pending. Later on, we have the retries, right? These retries over here, what it's doing is it's telling, I want you to try this task 3 times and 1 time every minute. Right, you can change this, it's modifiable. All right, so let's see this in action. All right, fingers crossed. Okay, so here we go, 1, 2, 3. As you can see, the response was almost immediate, but the status, as you can see here, is still pending. It's not completed. The payment is just pending. It's still pending. How does this look like through the user interface? Okay, username demo, password demo. Please don't remember that. All right. So my process is the number 3. So what I'm going to do here, I'm just going to look for it. As you can see, I've been doing a lot of homework. We're going to dive into payment version 3. And here we go. All right? This is the process that we created with Java code. And here we have an asynchronous task. Let's imagine this is the payment service. And we have one instance there that is going to retry itself 1 time every minute, even if the credit card service is slow. So there you go. That's asynchronous. Now, next example that we have here is, what if you want a synchronous response? What if you want to, for example, say, okay, if the credit card service is slow, I want you to be synchronous and tell me, yes, it's working now. You can do that as well, no problem, right? So to do that, I first need to make my credit card service fast. So just a second. All right. There we go. So now it's running again. Again, what if you want your service to be synchronous? So 1, 2, 3. There you go. So I did another request, payment request, and now the status has been completed. All right? And so that was synchronous. It was an immediate response. And, well, if you prefer, right, you can go for the asynchronous way or the synchronous way. We're going to talk about that later. So what have we learned in these last 4 demos? What we learned is that we now have a state machine which you can use to orchestrate your services. You can use to handle state. All right? Now, like I said in one of the previous slides, Workflow Engines is not a centralized solution. It's not something that we don't want to control all of your services and tasks and systems. That's not the idea. The idea is that each service can have its own workflow engine, an own process, as you see here. Okay? All right, so far, we've learned that the client should have retries. Okay? This can help you avoid some of the challenges in microservice integration. So let's continue the presentation and talk more about what other things must your client have and your service provider have to be successful. All right, so again, let's start with an example. Here we have a payment being processed, and you have this website that is telling you, hey, please do not reload the website, or please do not close the window, because if you close it, problems will happen. This is something that you don't want. What you want is something like this, right? Something that tells you, hey, it's okay if you close your website, it's okay if you reload your website. Okay? This is what we like to call idempotency, or being able to accept 20 similar requests with the same information, but having the system or the application accept only one and recognize only one, have the right correlation. Okay, so this is better, right? Because the reality is that there's so many problems that can occur between your client and your service provider. Network problems, system failure, power failures, anything. Okay? So how can we go about these types of scenarios? All right? So the first thing you could do here is you could have this simple process that says, okay, charge credit card. But if after 5 retries, it didn't work because there was a power failure or XYZ type of exception, right? I want you to do something else. I want you to refund the money to the customer. So you could do something like that, right? This gives you the capability to handle many different types of exceptions without worrying what exception to code in your programming language, right? Again, there is state in this. We're handling state while we're doing all of this. So that's very important. Again, I'd like to make a quick remark on how each of your services must have a workflow engine embedded in them. All right? So here you have, for example, a barcode generator. This service has its own workflow. All right? And here we're doing like, okay, barcode generator, try to create your barcode 3 times, 5 times. If it doesn't work, right, then do something, right? But the cool thing about this approach is that you don't depend on whether or not checking worked or not, right? You're keeping it very local, right? Each service, the idea here is that each service should have its own workflow. Now, if you want to learn more about if you want to know more about the different architecture options, we highly recommend taking a look at this article. All right? And we'll share this with you. We'll share the presentation, and you'll have access to this link. But for now, let's talk about what have we been using so far. In the demo that I did, the last 4 demos, we had 2 services. Each service was being run using Spring Boot and a simple Java application, and each service had its own Camunda workflow engine, all right, and monitoring tool. Each service also had its own workflow, its own process. As you can see, again, each service should have a workflow. And it's a recommendation. It's an architectural option, something that you could use if you wanted. Again, for those who are more familiar with application servers like Wildfly or Tomcat, you can also deploy the workflow engine using application servers, right? You could have an application server with 10 services if you'd like, right? Using Tomcat, and maybe even another you can have a Wildfly in another location and have them communicate through the REST API if you'd like. Now, for those people that did not raise their hand when I asked about Java, if you're a Java shop, well, there's also an option for you guys. You could, for example, have the workflow engine running on one side, and then you could communicate with that engine through the REST API and use your preferred programming language as long as it's compatible and can talk through the REST API to our engine, right? Such as C# or Node.js. All right, so to do a quick recap on the last few slides, let's talk about synchronous versus asynchronous. Okay? So the idea here is that your microservice or your application should be synchronous first, meaning that if everything is magically okay, right, the response should be synchronous. The payment request application should be, okay, here's the request. Oh, thank you. The answer came back perfect. That's the first approach. But then if it's not like that, if it's not synchronous, you should also allow your service to be asynchronous. Allow for failure, basically. That's the idea here. Now, how could we, now looking back at the example of the airplane, right? Okay, we're trying to check in, we're trying to get our ticket, right? And the customer also wants synchronous. No, all right? It's okay not to be synchronous all the time. Asynchronous is okay. Things fail, so. And I really like this quote, right, which says, synchronous communication is the crystal meth of distributed programming. Stay away from it, if you can, because things will fail. When you have distributed system, you have so many services. Of course, this is just a joke. Don't take it to, anyways, it's a little bit funny. Okay, so now we've talked about asynchronous, all right? Let's see what challenges what challenges this brings to your organization. Of course, it's not something perfect. It's not something that will work all the time. But there are ways to solve those challenges. Again, let's go back to our airplane example. And let's look at check-in and barcode, okay? So you have check-in requesting an airplane ticket. And then you have the barcode application saying, hey, sorry, I'm failing. I'm sorry, I'm failing. But then you have the check-in application trying again and again and again. So you need to monitor this, right? I mean, what happens if after 5 days, the check-in is still trying because the barcode application is just shut down? Somebody decided to play a joke and disconnected a network cable, or somebody shut down your AWS instance or something. That would be horrible, but something like that. The idea here, remember, is always maintain the failure between this scope, between check-in and barcode. So let's look at an example on how we could monitor these timeouts. All right, so let's play with this BPMN workflow. All right, so we start the workflow, and we send a generate barcode command. Later on, we have to wait for that barcode. If the barcode hasn't arrived after an hour, we will resend generate barcode command every hour until we receive that barcode. Right? You can do this with BPMN. Later on, after that is successful, we will send the boarding pass, okay, to the customer end user, to the angry customer, in that case me, most of the times. But then we will wait for the mail confirmation, right? And every hour, again, we will resend the boarding pass until the customer can check in successfully, right? This is monitoring, right? You can do this in with your applications. Now, and then a little bit more advanced BPMN here, right? You could use a start timer event here and say, hey, if the customer's flight is 4 hours before departure, I want one of my airline employees to call the customer and tell him, hey man, I'm sorry, I'm not able to give you your airline ticket. Please come to the airport and I'll give you your ticket here, right? You can do that, right? So very flexible. Now, at the same time, remember, we're doing all of this while maintaining state. All right, so far, this is what we've learned, some of the tips and tricks to avoid some of those challenges, right? So let's continue here. Question for you guys. Who uses a message bus? Apache Kafka, Rabbit, MQ? Wow, nice. All right, so next question for you. Raise your hand if you have no problems when operating your message bus. Yes, okay. Well, yeah, of course, it's painful, right? Raise your hand if you recognize any of these problems. Okay. There we go. Okay, so how can you use a workflow engine to help you avoid some of these, right? You will never defeat these problems. You can avoid them, maybe. But here's a possible solution, right? And this is more of a push strategy, all right? So in this case, right, we have service A with a workflow engine and a process, and it's pushing work to service B, okay? And it's maintaining state, just like I showed you in the demo, right? You could also have service A be pushing messages to your event bus, and then you have service B grabbing work from that message bus. Now, the cool thing here is, again, you are maintaining state. You can monitor all of this. You have visibility. Again, you can read more about in that document. Now, another approach here would be to, again, also, if you want to talk more about how you could defeat some of those problems, come visit us at our booth. But just as a quick reminder, I know I'm going through this a little bit fast, but at the booth we can talk more about it. All right, so another solution would be you have service A who has a workflow engine. All right? This workflow engine is creating work but not completing it. This service is creating work, and then you have service B that is fetching work, is asking for work. Service B is asking service A, hey, what work do I have? Give me work. Right? So imagine how you could scale with this, right? How much visibility you could have, how much monitoring you could have. All right? You can have multiple services fetching work from the main workflow engine, right? So performance, scalability, right? And sometimes even less errors, okay? Because you know the state, you know what's going on. All right, so now distributed transactions, all right? So in distributed systems, I think distributed transactions is something that is very important. Or even if you have a big monolith, right? You have these transactions that you have to do that require 3 tasks to commit at the same time, and you have to maintain consistency, right? But as things get larger and larger and larger, right, you start facing these transaction manager issues. Who has faced transaction manager issues from here? Okay, right? You have to go inside the logs and delete information, or even add information, copy-paste information to make things consistent again. But the reality is that this requirement is still something that companies have to do, even in the microservices world. So, a solution for these challenges on how to avoid them is to use compensation, right, with the power of BPMN. So let's walk through this example. So here we are requesting a payment, right? We need to perform payment retrieval requested. Later on, we need to deduct existing customer credit. Now, this work is going to be done by an external worker, right? Not by the workflow engine. Anyways, if everything's okay, we then charge the credit card. But if that fails, we can compensate and go back to this to the first task and restore customer credit. All right? So that's how you can avoid some of those challenges in distributed transactions. This diagram or this pattern is known as the Saga pattern. There's more information about it online, and so I encourage you to take a look at it. Again, you are maintaining state, so you know what's going on. Now, of course, not everything is super amazing when you're using a workflow engine. Yes, it has eventual consistency, meaning that sometimes a piece of information might not be consistent with another piece of information. You might have two runners that are not running at the same speed, but for our customers out there that are using this solution, they're happy with it because it's very small situations when you cannot maintain consistency when you're using this type of approach. All right, so last demo of the day. And what we're going to do here now is we're going to use the same process that I just explained. We're going to deploy it, right, in service A, right? Workflow, it will be using a process. It will be using a workflow engine. And then we're going to have service B, which is going to be an external application. This application is going to be asking for work from service A to complete it. Again, if this service goes down, our service A workflow doesn't care. The process continues. You can have 100 other applications, but you can still move on. You can still continue your process. No problem. All right, so let's take a look at that. Okay, so what I'm going to do here is version 6. I'm going to create a couple. Let's do maybe 10. Okay, 5, 6, 7, 8, 9, 10. Okay, so I've created my instances, right? I've created this work. Let's see how that looks in the operating tool. All right. All right, payment version 6. All right, and as you can see here, we have 10 instances in the deduct existing customer credit waiting to be completed. All right, they're waiting to be completed by an external worker, by an external application. All right, so let's go ahead and complete them, because we have work to do. Okay, so here we go. This is my external worker. It's a simple Node.js application. And I'm going to go ahead and start the application, which will look for work. There you go. As you can see, it has completed all of the work. All right? Now, if I go back to my payment requester application, and I request another, let's see over here, right? And this is, of course, performance in my local laptop. Okay, go ahead and say send. There you go. The Node.js completed the work in less than a blink of an eye. Right? And I can do more of them if I wanted to, because it's very fun. I like seeing that. Anyways. Okay. Now, let's take a look at our monitoring tool and see what happened. Okay. I just need a quick refresh. And as you can see, my one second. As you can see, all of my work is gone. There's no more work to be completed. But where did that go? Well, you can look at the history in this operating tool, and you can see where most of the work was completed. Okay? You can identify if there was any problems, if there was any incidents, anything that you like. In this case, right? In this case, we had a happy path. We made a lot of money by charging the customer, no problem. But sometimes, actually 61 times, the credit card payment failed, right? Because it was slow, because there was a network problem, or whatever. So we had to be consistent, we use compensation, again, to restore that customer credit. All right. All right, so almost getting to the end of the presentation, right? This is all of the things that we talked about. These are the tips and tricks for you guys in your intent to move into the microservices world, or if you're already in it, right? These are the things that can help you avoid some of those challenges. Again, while maintaining state, right? The workflow engine can provide you with that state. Now, a quick reality check, right? This is one of our customers. Who goes to the gym? Anybody? Okay, yeah. Anyways, so this is one of our customers, 24-hour fitness in the United States, and they're using Camunda BPM to manage their services, their human tasks, their IT applications, their application logic, right? Every day, they execute around 20 million processes. Okay? Now, for those that are more into the Apache Kafka approach, right? We have an example online over here. Now, I won't go through this example to allow you guys to ask some questions, but very quickly, it's a simple payment like an Amazon Dash button, right? You click the button, and later on, you create, by using the workflow engine, you create all of these events, all right? And you interact with the message bus, you create the message, you retrieve the message, and you work and you orchestrate, right? Again, you have visibility to all of that information. Now, we talked about CB today a little bit, right? CB, we have also online an example, right? You can see how, in this same example that I just showed you, how you can replace Apache Kafka and use CB. Now, this is a development project. It's open source. If you want to try it out, go ahead. It's not, not a supported product by Camunda, right? It's open source, user-friendly. It's something for you to try if you want to. That's the GitHub link. Again, I'll share these slides with you. Okay, quick reminder, right? In this example that I just showed you, right, we have multiple services, and the important part here is that each service is living with each service has a workflow, has a process that is orchestrating that service. Reality check, all right? We have Zalando.com selling shoes. They're using this approach that I just showed you, right? And in Q2 of 2017, Camunda helped them sell 22 million shoes. He helped 22 million people dress better. So that's important, I guess. So again, this is just an example of proven track of success. All right, so workflow engine, yes. There's many things that you can do with it. Today, we just focused on microservice orchestration with an e-commerce order, kind of like a payment and a credit card charge application, right? If you want to learn more about this, please come visit us at our booth, right? Now, before I let you go, guys, I just want to give you a couple of key points. Is be aware of the complexity of distributed systems. Okay? You make sure you know the strategies when working in this environment, like Circuit Breaker of Netflix, like any other workflow open source engine that you have out there, right? And of course, like Camunda, well, because I'm here because of them and very happy for it, right? Camunda is maybe a solution for you. So I invite you guys to read this article, get to know more about this solution, and see whether or not Camunda is the right solution for you. It may be, may not be. Again, we are located right in number 6, and we're here right now. Anyways, If you want to know more information, because maybe you cannot stay here today, please, I invite you to contact Andreas Stange over here, or Mauricio Bittencourt over there. So without further ado, thank you so much. Do you guys have any questions?